This is the interconnections or interfacing of 8086 with the independent processor. We will discuss how this independent processor is being connected with all other devices through its through its various pins. First of all, we will discuss about these three pins of the independent processor. The first connection is the clock signal, which is actually generated by the clock generator. So there will be a common clock to both these processor. The second is the ready pin. This ready pin is also a common ready pin that this clock generator will generate, and this pin actually ready the both these processor for any work. The next important is the reset pin. The reset pin actually initializes both these processor for any new tasks which both the processor has to perform. The another important connection of this independent processor is with the main processor is through the request grant pin. This is the request grant pin. Whenever this independent processor has to perform its task which has been provided by the main processor, this will actually be activated by the request generated by the independent processor to the main processor, and that request is actually granted by the main processor to the independent processor through this pin only by the grant signal. So request and grant signal are actually transferred by this connection only. The another important connection between these two processor is the INTA and the INTA pin. INT pin of the independent processor and INTA, that is interrupt acknowledge pin of the main processor. Whenever the independent processor completed its task which has been provided by the main processor, and this information is actually be conveyed to the main processor through this INT pin. Through this INT pin, an interrupt is generated by the coprocessor through the interrupt request controller, and through this line through the INTA pin of the main processor, that independent processor has completed its task. So this is actually be done by these two pins of the independent processor and the main processor by the involvement of the 8259 interrupt controller. And this interrupt controller also being activated by the data enable pin of the 8288 bus controller. This is the data enable pin of the 8259. So this is interrupt controller is being activated by the bus controller through the DEN pin of the bus controller. The next important connections of this independent processor is the CA pin. For any task to performed by it, this CA pin should be at the high state, that is digital 1 state, and this digital 1 state is actually transferred through this AND gate. If we know the AND gate truth table, the output of the AND gate will be 1 when both its input at the high state. That is, if both input at the high state, the output will also be at the high state. Here we required the high state at the CA pin to activate the independent processor. So for that the input at this AND gate should be 1 and 1. So both inputs of the AND gate should be at the high state. Now for example, there is some work, there is some task which actually 8086 has uh, to allot to the independent processor, and that information, that control signal is actually generated by the 8086 that some task has to be performed by the independent processor, and this is actually transferred through these control signals when in the form of input output write commands. Whenever there is a out instruction from the 8086, whenever there is a out instruction in the 8086, this will activate the input output write command signal. This is the input output write. That means there is a one input output device, and this input output write command is actually at the 0 state when it is activated. So a digital 0 is actually transferred from these control signals to the AND gate, and before input to this AND gate there is a NOT gate. This will convert this digital 0 into 1. So a digital 1 is inserted when there is any control signal for independent processor. That is, if there is a out instruction and that control signal in the form of input output write control will be transferred in the form of digital 0, and this is got converted by the NOT gate into 1. Now the next connection of the AND gate is the address decoder. This address decoder is actually the address bus of the, this is common address bus of both this processor. If there is a address for the independent processor, there is address in the memory for independent processor, then that address is actually be decoded by the address decoder, and digital 1 will be inserted into the AND gate. If there is no address, then digital 0 will be inserted. So when there is any task has to be performed by the independent processor, there will be a digital 1 to the input of this AND gate, and the output will also be a 1. So CA pin of the independent processor will be activated. For any additional task to be performed by the independent processor, SCL pin also should be at the high state, and this high state is actually traveled from this A0 pin of the address bus. So A0 pin, actually the first pin, initial pin of the address, it will actually transferred the digital 1 from address bus to the common address bus to the independent processor. This will activate the SCL pin of the independent processor. Till now we have discussed all these connections about this independent processor with other devices. We have a status signals that being shared by these two processors, S0 to S2. We also have another important connections between these two processors is the VHE signal. This VHE signal actually enables the bus. This VHE signal actually enables the bus. It tells the bus that they will be activated, and this VHE signal tells the bus when they will be activated is actually when there is a digital 0 state, because there is a complement sign over it. So when this pin VHE signal is at digital 0 state, then the bus will be at the enabled state, that is bus high enable. So all the buses will be enabled through these two pins. There is also a connection of independent processor through the address bus, that is the, this is the address bus that is actually shared by the 8086 processor, 8282 latch, 8286 transceiver and an independent processor. The another important pin is the min-max pin of the 8086 processor. Whenever we have to interconnect any input output device with the main processor, this pin should be at the low state, that is max mode. This is our pin min and this is max complement. So whenever this pin has to be at the maximum state, maximum model max mode, this pin should be at the 0 state, and that 0 is actually be inserted by grounding this pin. This is all about the interconnection of independent processor 8089 with 8086 main processor.